Let's look at another example of a redox reaction balanced by using the oxidation number technique. Here's the reaction that we are confronted with. Once again, we go through each reactant and each product, applying the rules for assigning oxidation numbers. And then we inspect what we've come up with, and we notice that antimony is going to be oxidized and give up 5 electrons, and nitrogen is going to be reduced by 3 and gain 3 electrons. So as we've done in previous problems, we will look for a common multiple, in this case 15. But I noticed something here. I noticed that if I'm going to get 15 electrons being given up by the antimony, I notice I'd have to put a 1.5 in front of the antimony oxide on the right side to get me 3 on that side. And I'd rather avoid that. And so instead of going for 15, I'm going to go to the next multiple that will help me avoid the fractions. And so that means going to 30. So in order to have a common multiple of 30, that would involve 6 antimonies and 10 nitrogens. So now I go into my equation. I put a 6 in on the left side and a 3 in on the right side, so I end up with 6 antimonies on both sides. And then I go ahead and take care of the nitrogens. I need 10 on both sides to get the 30 electrons that are going to be accepted by the nitrogens, so a 10 on each side, in front of the nitric acid and the nitrogen monoxide. As we've seen in previous problems, now I want to go through and take care of the other elements. And the first thing I'm going to do is go after the hydrogens. This is something we haven't run into. To take care of the hydrogens, it doesn't look like there's any on the right side, but you have to remember, these things are taking place in aqueous solutions. These elements have to come in contact, and they're occurring in water. So the way we take care of the hydrogens that we need on the right side is we're going to have to add in the appropriate number of water molecules. So here's the modified equation I've already come up with. I'm going to add water in on the right side, H2O, and then obviously I need 10 hydrogens. Well, that's going to involve adding 5 water molecules on the right side. As we've seen repeatedly, with oxygen being so ubiquitous, it's probably already balanced. And on the left side, I've got 30 oxygens. On the right side, I've got 3 times 5 is 15, plus 10 is 25, plus 5 is 30. So they're also balanced. So in this problem, we saw something a little different. Don't get thrown by this technique. These are occurring in solution, and the way to take care of things is realize water is also present, and that's how we take care of the hydrogen and the oxygens that we needed.